We have been solving this linear programming problem, and in one of the videos I showed you how to solve it in Excel, and the result of that Excel program was not only it gave you the answer report, but also it gave you the sensitivity report. The sensitivity report has several things to consider, and in the last video I showed you what where this 8.75 and 23.75 from the allowable increase and decrease was obtained, and I also explained the meaning of it. In this video I want to explain the shadow price and also explain to you how this number 4.375 is obtained. Now, this linear problem, we already know that it has the optimal solution at 8, 10 with the maximum value of the objective function as 970. And while we were solving this, we named these three inequalities as the inequalities for the constraint 1, constraint 2, constraint 3. Now for that constraint, we want to know what would happen if we change this limit. So remember that C1, C2, C3 were some kind of ingredients used to make the trail mixes and protein bars. And it was limited because they were working with some vendor which were able to provide these numbers every day. Now, what if the manufacturer found out that they could get this ingredient C1 from another vendor, some extras, so they can add like 1 or 2 to this number? Now, would they want it? Should they go for it? That's the question that one likes to answer, right? And it really depends on how much the other vendor will charge. Probably they already have the vendor that gives you the lowest price, but the other vendor might be charging for slightly higher price, so what's the price they should be willing to pay? That's the kind of answer that the shadow price would be answering. Okay, so imagine this. Let's say that this 48 was instead changed to 49. So now the new inequality after the change would be the new inequality after the change would be x plus 4y less or equals to 49. Okay. So right now we're just looking at what if it was increased just by 1. Now, because the problem changed, of course, the solution would change. So these numbers, x and y, would change. To actually solve this again, you'll need to, unfortunately, solve these system again. But usually, the binding constraints remain binding, and the non-binding constraint is still non-binding. Oh, I forgot to explain to you how to figure out which one's binding or not. Okay. See, if you take the optimal solution and plug it into the left side, and it's equal to the right side, then it's binding. And if you plug in these 8 and 10, and it's actually strictly less than the right side, then it's non-binding. So, for example, if I have 8 in here and 10 plugged in here, so that's 4 times 10, and that's equal to 8 plus 40, which is 48. And that is actually equal to the right side, which is 48. So this number here is same as what you calculated from here. So in that case, this is binding. I'll put a check mark for the binding. Same thing, if you plug in 8 times 3 is 24, plug in 10 times 4 is 40, 40 plus 24 is equal to 64, so that's binding. What about this one? 4 times 8 plus 2 times 10, 8 and 10 are the optimal solutions, and you multiply this, that's 32 plus 20, and that's equal to 52. That's strictly less than the right side, right? So in this case, this is not binding. Now, if the constraint that's not binding is increased, that really doesn't impact anything because, I mean, this already had 10 slack. So there's a slack of 10. Slack is 10. That means even after manufacturing, you have 10 left over. So getting new stuff will only increase the leftover and really not contribute to how much more trail mixes and protein bars you can manufacture. So one immediate thing that you learn is that when you have a non-binding constraint, that is going to give you 0 shadow price, because that's not going to increase this maximum anyways, and since there is no increase in profit, the manufacturer shouldn't be trying to get more of this. So shadow price is like 0. And as you can see in the Excel file, if you look at the non-binding one, we said C3 is non-binding, and the shadow price is indeed 0, right? Okay, back to here. Okay, let's go back to our calculation. We decided to change this. So remember, these two are the binding ones, C1 and C2. And we decide to increase this by 1. So x plus 4y less or equals to 49. And 3x plus 4y. The other ones are kept the same. Okay? And if you look at the sensitivity report, it has this allowable increase and allowable decrease. The meaning of this is that if you increase this 48 by less than 16, or maybe up to 16, this C1 continues to be a binding constraint. I'll explain why in the next video. But for now, let's just say that since adding 1 is still allowed here, this will still be a binding constraint. Okay? So we know that C1 is still a binding constraint and C2 will still be a binding constraint. Those won't be changed if you just increase by 1. Now, what will change, however, remember that this point was the intersection of two lines, this line and this line. This one here is C1 and this one is C2. And changing this C1 by this number, 49, will just change this, alter this C1 line slightly. It will actually make it go slightly above, but you don't have to know that. Let's say that it goes slightly above, okay? Now, what that does is that it will change the optimal solution, right? It was here and now it should be over here. And since the optimal solution happens at the intersections of constraints, we have to solve the system of equations again. The system of equations that we have to solve is x plus 4y equals to 49, and also 3x plus 4y equals to 64. Now you can use any of the 4 methods I explained in the previous videos to solve this, but I like just subtracting them because if you subtract them, then 4y cancels. So this is negative 2x, and this will be negative 15. So that's going to give you that x is equals to negative 15 over negative 2, which is 7.5. Now once you have that number, you can plug it back into any of the equations and solve for y. I'll plug it back in here. So that 7.5 plus 4 times y is 49. Subtracting 7.5 both sides, you get 4y equals to 41.5. And dividing that by 41.5 by 4, you get, let's see, you get 10, 0, and 375 would be what you get. Okay, so you can check this calculation with a calculator. All right, so you get this new binding point, or another name for binding point is the optimal solution. You get a new optimal solution. Now, in turn, if you have new optimal solution, that is going to change your objective function, right? So if you change the objective if you plug these numbers into the objective function, you get the changed value of the objective function. So let's do that. 40 times 7.5 plus 65 times 10.375. Okay, I definitely need a calculator. Wait. Okay, I just used my calculator and it tells me that the number is 974.375. Okay, so we get this new objective maximum. Now compared with our previous one, what was our old objective maximum? It was when we had 40 times 8 plus 65 times 10, we had 970. 970. So what's the difference? If you do 974.375 subtract by 970, you get 4.375. Okay, what does that mean? That means that if you increase the C1, if you get an extra C1 ingredient from some other vendor, then you're going to have a additional profit of 4.375. Well, what that means is that if the new vendor says they're going to sell the ingredient for, say, 4, let's say this is in dollars, if it's $4, then it's less than this, so you accept it. If it's more than 4.375, then actually by getting that more ingredient, you'll actually have a reduction in the actual profit because you're going to be losing money. Okay, so that's the real meaning of the shadow price. So the shadow price tells you how much you should be willing to pay additionally for that new ingredient. Okay, just to make sure that we understood this well, let's try to get the C2's shadow price. All right, to get the C2's shadow price, remember C3's shadow price is 0 because it's non-binding. And when you try to get the shadow price of one ingredient, you have to fix the other ones as the original value. So here, a moment ago, I changed this into 49, but we should revert it back to 48. And then this one I increased by 1. Okay. So I increased by 1. And then I changed that into system of equations. X plus 4y equals to 48. 3x plus 4y equals to 65. And then subtracting it, we get negative 2x. 4y minus 4y is 0, so that goes away. And then this will be 17, negative 17. Dividing, we get x equals to negative 17 over negative 2, which is 8.5. Now when you have x equals to 8.5, plug that back in here, so that 8.5 plus 4y is equals to 48, and then 4y would be 39.5. If you subtract 8.5 both sides, this is what you're going to get. And dividing by 4, you get 39.5 divided by 4. You can use your calculator and you're going to get 9.75. No, it's 9.875. Okay, that's your new y value. Your x value is 8.5. What do you do with this? You plug it into your objective function. Now, let's calculate the objective function. 40 times 8.5 plus 65 times 9.875. And I just used the calculator, and my calculator says it's 981.875. Okay then, what is the change from the original maximum. Remember, our original maximum was 970, so if you subtract them, you get 11.875. And if you check with the Excel, you see 11.875. So that's exactly the same. So hopefully this was a good review of how to get the shadow price.